Heat transport. Always when a temperature difference exists between two different locations, heat is transported from the warmer to the cooler region. Such heat transport is very important for many technical problems, and also for different measuring methods. In many cases, one try to maximize the heat transport, for example, in cooling heat generating systems, or in other cases, it's minimized for heat isolating devices such as refrigerators. Um, there are essentially the three mechanisms of heat transport: convection, heat conduction, and thermal radiation. Convection. When the bottom of a container with matter is heated like a figure, um, the lowest liquid layer is heated first, its temperature increases and its density therefore decreases. This causes a rise of this lower layer through the layer cross we skim down. This process is called convection. It results in a heat transport from the warmer to the cooler region. This convection of liquids can be demonstrated by cording. So the lower layer and observing how this core layer moves upwards when the bottom of the core is heated. Convection. Convection occurs also for gases. It plays an essential role in the Earth atmosphere and it's responsible for the generation and the equalization of pressure difference, like a figure. Um, Air rise from the bottom just above the Earth's surface, creating a local low pressure region. Um, so the wind transports not only mass but also heat. This mass heat transport depends on the wind velocity and the temperature difference between high and low pressure region. The wind flow can be either laminar or turbulent, depending on the boundary conditions. Although the total energy received by the air is due to radiation for the sun, and so the local distribution of this energy is essentially determined by convection. This illustrates by sudden local temperatures changes when the wind direction changes, although the intensity of the sun radiation has not changed. Heat conduction. If we heat one end of a metal bar by keeping it over a gas burner, we find that its other end also gets hot after some time. So heat is transferred from hot end to the bar to its cool end. In this case of heat transfer, there is no movement of molecules or particles of the material of metal bar as shown below in the figure. Contrary to this situation for convection or heat conduction, only energy transport takes place, but there is no mass transport. Heat conduction can only occur in matter, and in vacuum, no heat conduction is possible, while thermal radiation also takes place in vacuum. Um, Otherwise, we would not receive the sound of radiation. The heat pipe. Often the problem is that heat produced in a volume V should be extracted as effectively as possible in order to reach a sufficient cooling power for the solution of this problem. A special device was developed which use evaporation of a liquid on the hot side and the condensation of the vapor on the cold side. This heat transport occurs by convection. This heat pipe allows a heat transport through the unit area that is larger by two orders of magnitude than can be achieved with metals. The heat pipe. A tube of metal or another material is connected at the hot side left and with the volume at the temperature T1 that should be cooled, and on the cool side with a cooling bath at T the T2 less than T1. Um, the evaporator is filled with a substance that has an evaporation temperature T, T sub E less than T1 and melting temperature Tm less than T2. For instance, if water is used, the temperature should be T1 greater than 100 Celsius degrees and T2 greater than 0 Celsius degrees. That's all for today. Thanks for watching.